There are over 500,000 individuals with upper limb amputations in the United States alone, and approximately 20% of these are transradial amputees who will benefit from the use of our prosthetic hand. These individuals have a variety of options when it comes to choosing a prosthesis. Many current devices within this industry implement myoelectric control of the prosthetic device. The most popular of these is the Autobox sensor hand, a simple 2-digit mechanism that only requires control of opening and closing. While more biomimetic prostheses exist with a full 5 digits and the ability to perform all the most important natural grasp types, they are much more difficult to operate. They require precise patterns of muscle activation for correct use, which can be draining on the mind and body of the amputee. They are often abandoned for prostheses with simpler control designs.
The VisioGrasp uses a fully articulated hand prosthesis. However, it aims to simplify the control of this more complex prosthesis by providing object recognition in real time. The camera, attached to a pair of glasses, will record continuous video that will be used as an input to an object and shape recognition algorithm. The detection of a familiar shape will precondition the prosthesis into one of its many grasp types, thus simplifying the control scheme to a simple open-close design for the individual.
The design of the VisioGrasp will begin with prototyping of the object and shape recognition algorithm. This will involve multiple iterations of the software, fine-tuning it first to recognize common household objects and second to recognize shapes more generally. The control software will be designed in conjunction, adapting that of an existing prosthesis to incorporate a preconditioner and a simple open-close position-based controller using EMG from the flexors and extensors to determine the degree of grasp closure. Finally, the two components will be integrated and tested to ensure that identified shapes are associated with the correct preconditioner on more than 90% of attempted grasps, and that the manipulation of the prosthesis is simple and intuitive for the user.
The design, development, and implementation team consists of software, design, manufacturing, and quality engineers, as well as business marketing representatives to push the product to market. Taking this device to the market requires registration with the United States Food and Drug Administration as a Class 1 device. Prerequisite devices allude to external upper limb prosthetics and eyeglassware. As a Class 1 device, the VisioGrasp requires GMP and other relevant documentation.
The estimated net present value of VisioGrasp is $450,000, assuming $2 million in initial costs and an average of 800 units sold per year at $500 per unit. However, the net present value could be much higher with a higher purchase rate and the introduction of new amputees into the market. The VisioGrasp will provide improved quality of life and simplicity of control to users of multi-digit myoelectric prosthetic hands.